this is version A. You know it's version A based off of what's on the side. Chapter 5 test, match cosine of 75 degrees. If you recognize, this is the sum identity of cosine, cosine, sine. Change the sign, so 30 plus 45 gives me cosine of 75, D. Cosine of 210 is E. Cos, sine, sine, ob. Change the sign. This is the sum addition of cosine. 60 plus 150 gives you 210 degrees. Here, this is the negative angle identity. You just take out the negative sign into the front, straightly looking at your formula sheet. Sine of 105 degrees is B. Sine, cosine, there's the sandwich. Sine stays the same. 45 plus 60 gives me sine of 105 degrees. Sine of 15 is cosine of 75. This is called a cofunctions. You take 15 degrees, put it back in there, and you get, if you take the 75, so cosine of an angle equals sine of 90 minus theta. So if you take in the 75 and put it there, you'll get cosine of 15. So you'll notice that these are complementary. Cofunctions are complementary. And the last one, number 6, tangent of 40. That is cotangent of 50. Those are cofunction identities. Question number 7, multiple choice, solve the interval on 0 to 2 pi, add 1, divide by 2, cosine of x equals 1/2. Switch those, you're taking the inverse. Where on your unit circle is cosine 1/2? That's 2 places, that's pi over 3 and 5 pi over 3. Question number 8 says fill in the blank as best as possible. To get any of these answers correct, it's all or nothing. Cosine squared 105 degrees minus sine squared 105 degrees. If you just take out, instead of the degrees, you're putting in theta, you realize that cosine squared theta minus sine squared theta is cosine 2 theta. That's a double angle identity. 2 times the angle is 105 degrees, so you have cosine of 210 degrees. We're not looking for cosine 200 degrees. You can actually simplify that even more. Cosine 210 degrees is negative radical 3 over 2. So again, if you miss the negative sign, you got 0 points. Question number 9, tangent of 90 minus theta equals cotangent. That is the cofunctions. Cofunctions are complementary. Question number 10, this looks like the Pythagorean identity. Cotangent squared theta plus 1 equals cosecant squared theta minus theta. And so if I subtract 1 on both sides, that gives me cotangent squared theta by itself. So that's cosecant squared theta minus 1. So you just had to put in cosecant squared. And then here, this is the, which identity? The reciprocal identity. Question number 7. Remember from the last quiz, you should not be dividing by sine on both sides. You subtract sine. Greatest common factor is sine. You have a set equal to 0. 0 product rule. Where on the unit circle is sine 0? That's at 0 and pi. Add 1, divide by 2. Take the inverse of 1/2. Where's sine 1/2? That's pi over 6 and 5 pi over 6. That'd be their choice, D. I gave you guys a 5x5. This one had a bunch of freebies. 2, 3, 3, 1, and another 3. I chose to start here where there were 15s. 2 numbers that multiply to be 15. There's only 2 numbers. It's a combination of 5 and 3. It's there twice. That side was out of 30 points, correct? Back side. Number 8, use the fundamental identities to write each expression in terms of sine and cosine and then simplify without fractions. So the first thing I did is I did not change it into sine and cosine because I don't want to do a fraction and then have to multiply it. You should have FOIL here. I'm using the box method. That's 1, negative cosine, secant, and negative cotine secant. Over here, cosine times secant. Secant here is 1 over cosine. Here, you can cancel when there's multiplication. So, big no-no. A lot of students, you see a plus sign, and then you try to cancel this out. Incorrect. All of this just turns into negative 1. You'll have a negative 1 and a positive 1. Those equals 0. I have negative cosine plus 1 over cosine. I need a common denominator, so I'm going to multiply this one by cosine over cosine. This gives you negative cosine squared theta over cosine plus 1 over cosine, common denominator. This is the reciprocal identity. That's sine squared. So a lot of students wrote here tangent squared. It would be incorrect. It would have been tangent squared if this was cosine squared, but I wrote sine times sine. So here, sine over cosine becomes tangent, and you're just left with sine. Tangent times sine is your correct answer. If you just transformed one of these into the reciprocal identities, I would have probably given you 2 points. If you recognize you got it down here, I give you 3 points. I'll stop there. Alright, so let's go over this problem. It says use the sum or difference identity for tangent of negative 15 degrees. That does say a negative 15 degrees, so the common mistake is, look in your paper, all our students wrote 45 minus 30. 45 minus 30 is a positive 15, not a negative 15, so that would have been incorrect. Second thing I'm looking for is using the correct one. So here it has a minus sign. They call this the difference identity of tangent. Tangent A minus tangent B over 1 plus tangent A times tangent of B. If you had that, you got about 2 points if you did the substitution correctly. So your A value for mine, now you could have chosen something else. You could have chosen like, I don't know, someone else pick a different number? 45 minus 60 would have been correct. So your numbers might be slightly different, but I was trying to look at the math that you were using. Mine is tangent of 30 degrees minus the tangent of 45. So I'm just putting the A's and the B's back in. Over 1 plus tangent of 30 times tangent of 45. Okay, here's the easy way to know a student doesn't understand what to do. If they evaluated a tangent of 30, if on your paper you have tangent of radical 3 over 3, that's incorrect. You're doing a substitution. Tangent of 30 can be evaluated as radical 3 over 3 minus 1 over 1 plus, just use the same value, radical 3 times 1. This is how I simplified my problem. How you simplify it might be slightly different. I made this a fraction by putting it over 1 and multiplying by 3 over 3. So I get radical 3 minus 3 all over 3. Then I take the division sign, which is here, and then whatever's in the denominator, don't do any flipping, just write it. So this is a 1 plus radical 3 over 3. Again, put it as a fraction, and then common denominator. So this reads 3 plus radical 3 over 3. Change it to multiplication, then I'm taking the reciprocal. Now, pay attention. This is by multiplication. You can cancel these 3's. Another common mistake I saw students is just trying to cancel these. You cannot, because those are not factors. You have addition. Do you see that? So now I have radical 3 minus 3 over radical 3 plus 3. Now, if you notice what happened here, I went from a fraction to no more fractions. Did you see that? Some of you really struggle with those fractions, and if you think about it, your goal is to eliminate the fractions so you don't have to deal with them. Here you look at the denominator, I have to rationalize. I just changed the conjugate, pluses and the minus. When I'm multiplying mine, I get 3, negative radical 3, negative radical 3, positive 9. When I multiply the denominator, I get 3, negative radical 3, positive radical 3, so those will cancel, that's 0, and then negative 9. Add those, I get negative 6. 3 and then positive 9 is 12. I factored out a 6. Factor out a 6. My 6's cancel. Negative 1 divided by 2 is a negative 2. Negative radical 3 divided by negative 1 is a positive radical 3. Negative 2 plus radical 3, or radical 3 minus 2 is your correct answer. Question number 10. So 9, that question I just went over to the same different numbering. Look here. It says, given alpha, that's the first part. Given beta, that's the second part. Use the trig identity. So if you didn't use trig identities, use x, y, and r, and you got the correct answer, I give you 0 points because you can't read. It says cosine of beta. So you don't need anything about alpha. So I'm just focusing on beta. Sine of beta is negative 4/5. Guys, use your parentheses. I can't tell you how many students did not use the substitution and they think the answer is negative 16 over 25 and they get like 41 over 25. Incorrect. Negative times a negative is a positive. Subtract it, square root, positive, negative. It tells you cosine is in between 0 and negative pi over 2. Negative pi over 2 is here. That means that here it is negative. Cosine of beta equals 3/5. Question number 17, I worked on the left-hand side. I used FOIL. You'll notice that the middle terms here cancel. 1 minus cosine squared x. Pythagorean identity, sine squared x equals 1 over cosecant squared x. Then from here to here, that's just the reciprocal identity, and I've proven the sides. So that's how I was out of 16 points. Alright, let me go over question number 10. Number 10. This question was the same question from your quiz, the previous quiz. Given cosine alpha equals 1 over radical 5 and 0, alpha is between 0 and pi over 2, given sine of beta equals negative 4/5 and beta is between negative pi over 2 and 0, use the trig identities to find cosine of beta. So if I'm trying to find cosine of beta, notice here that I can cross off this information. It's not needed. That's for you to decipher. Beta is between 0 and negative pi over 2. So from standard position, you're doing a clockwise rotation. So this is in quadrant 4. All students take calculus, so I know that cosine is going to be positive as my answer. Well, if I have cosine, I need to find cosine, and they gave me sine. Well, what's the relationship between sine and cosine? I can use the Pythagorean identity. Cosine of beta squared plus cosine of beta squared equals 1. There, I'm just going to substitute in sine of beta as negative 4/5 here. So negative 4/5 times negative 4/5. A lot of students are missing that negative sign, so remember when you're doing a substitution, it's in parentheses. So this whole expression times itself, so negative 4/5 times negative 4/5 gives me 16 over 25. This 1 here, I'm going to make it a fraction by putting it over 1, and then multiplying by 25 over 25, so that when I subtract, I have a common denominator. Subtract the numerators. 25 minus 16 gives you 9. The common mistake over here was if you left that negative sign, I don't know why students do that here, negative 4/5 times negative 4/5. For some reason they don't, if you do something like this, this is good. I'm putting a check here, this is good, this is bad. They do something like this. Then they think it's 16 over 25, and then think it's a negative 16 over 25, which is incorrect. So a common mistake was like 41 over 25. Here I need to take the square root of both sides. The square root of 9 is 3, the square root of 25 is 5, so you get 3/5. Remember, you take the square root, you have them both plus or minus, and determine if it's plus or minus. We're in quadrant 4, so cosine of beta equals 3/5. If you got the correct answer, but you didn't use trig identities, because it says trig identities, I gave you 0 points. So a lot of you guys are trying to draw triangles. That's from the previous chapter. This question number here should say number 11. Verify the identity. You're going to work on one side. I thought the left-hand side was easier to work with. 1 plus cosine x times 1 minus cosine x. Here, a common mistake is for students to think that this is the Pythagorean identity. Remember, the Pythagorean identity with sine and cosine has the power of 2. Right here. Notice that these just have the power of 1, so you can't do that. So when you FOIL, or you're multiplying them, you're going to have 4 terms. 1 plus cosine x, 1 minus cosine x, multiply first, 1, negative cosine, positive cosine, negative cosine squared x. These will cancel. Negative, so you have 1 minus cosine squared x. This looks like the Pythagorean identity, make it match. So we want to say 1 minus cosine squared, so if I subtract cosine squared here, I get sine squared equals 1 minus cosine squared. There's a Pythagorean identity. And then you're very close to it, so then you can just use the reciprocal identity to get 1 over cosecant squared x. That side was out of 16 points. This side was out of 30, and then the test was out of 46. Hope that was helpful for you.
I love math.